ASK Aviation School.
Hello and welcome to my channel once again. Today we will be solving a very important numerical which is often asked in the DGCA as well as FAA and the EASA examinations. For the CPL, the numerical is on time. The question is, an aircraft departs from a point A whose coordinate is 35 degrees south and 168 degrees west to a place B whose coordinate is 5 degrees south and 164 degrees and 15 minutes east. The flight time is 08 hours 20 minutes and the departure time, and that is time and the date is 2145 hours on LMT. This is local mean time, and the date is 2nd of March. Now find the time, find the ETA, estimated time of arrival, at B in UTC as well as LMT. So this kind of a question is asked very often in the examinations. So we will solve this. Let me minimize this question a little bit so that I have some space to solve the numerical. First of all, when you have such kind of a question, it is always better to go step by step. The first step is to draw a line representing the aircraft track on that particular latitude. So the aircraft starts from the west longitude and goes to the east longitude. So therefore the Greenwich meridian will come in between, and the time at the Greenwich meridian what we use to fly is in UTC. That is the first step. And the second step, what we are going to be following is that we'll place those 2 points onto this line. The first point, that is point alpha is at 168 west, whereas point Bravo is at 164 degrees and 15 minutes. So as you know that the sun rises from east. Okay, so therefore the sun is going to be following the path from east to the west, and what I'm talking about is the apparent motion of the sun. So the time in the eastern side is going to be ahead of the time in the western side. So therefore in the eastern the sun rise will early, so therefore their local mean time will be ahead of those places which are at the westerly direction. So we'll have to keep this in mind when we solve this problem. So the time of departure, okay, now step 2 is I will write the time of the departure, that is at 2145 LMT on 2nd of March. So I need to convert, it is always advisable to convert the local mean time to the UTC, because all of us fly in the UTC, and it will be a kind of a common datum from where it can convert to any LMT. So now for that I need to know the difference in the longitude. So the difference in longitude is, this is 000 east west, it is west, 168 is the difference in longitude, and we all know that it takes 1 hour for the sun to travel 15 degrees. So therefore we will divide this 168 divided by 15 to convert this longitude into difference in terms of hours. So the difference in terms of hour is 11.2. So I need to convert that into minutes. So therefore I will subtract the whole hour, that is 11, okay, multiply by 60 to convert. So 11 hours and 12 minutes. So now the next step is using this difference in time, I need to convert the time of departure which is given in the LMT to the UTC. The time of departure is 2145 plus 1112, which is going to be 7523. 32 hours 57 means that I have already crossed 32 hours 57 minutes. That means to say that 1 day is already lapsed, okay, because it is more than 24 hours. So therefore I need to subtract 24 hours from here and find the time, that is 75, okay, so that is 80857. It is going to be at UTC timing 1 day later. So therefore it is going to be on 03rd of March. So the time of departure in UTC is 0857 on 3rd of March. So now I know the time of departure. So now the next step is going to be to find the time of arrival at point B by adding the flight time, that is 8 hours 20 minutes. So 0857 plus 0820, that means 7, 1 in hand, 8 to the 16, 1, 7, 17. This is UTC. ETA at B in UTC will be 1717. So now I've got one answer. The ETA at B, okay, in UTC is 1717 hours. Now I need to convert this UTC into the local mean time. The question also asks the local mean time. So now I need to know the difference in longitude. Once again, this is 000 and this is 164 degrees and the 15 minutes. So 15 minutes, which when converted into decimals of hours will be 0.25, right? So I need to convert this 164.25 divided by 15 is equal to 10 hours, that is 10 hours, 10.95 hours. So that means to say that I subtract that whole hours, that is 10, okay, and the leftover is decimal 95 multiplied by 60, which is going to be 57 minutes. So therefore the difference in time from the Greenwich meridian to this meridian is going to be 10 hours and the 57 minutes. So 10 hours and the 57 minutes. So since this place Alpha Bravo is in the east of the Greenwich meridian, the time will be again ahead. So I need to add this much. So 7 to the 14, 1 in hand, 5, 6, 7, that is 1, okay, and then 1 in hand here, 17, 28, so this is 2814 hours. Once again, 24 hours has lapsed, so I have to subtract 24 hours so that it changes into the next day. So 1, 4, okay, then 0414. So the time of arrival at point Bravo in the local mean time will now be on 0414. Okay, this was on 3rd of March, 03 of March. So now this will be on 04th of March. This is at local mean time. So this is how we solve this kind of a question to convert one time to another time, that may be for any latitude or for any longitude. Thank you, ladies and gentlemen. If you have not subscribed so far, kindly do subscribe and share it to your friends so that they also benefit from this. Thank you, ladies and gentlemen. Have a nice day.